Hello. Sorry if this has come on and gone. Hello and welcome to today's live stream where we're going to be looking at past paper 3 for GCSE. As I said, there's massive crossover between functional skills and GCSE, and I know that a lot of you are doing the same thing. So in today's session, what we're looking at is we are looking at the last paper in the GCSE. So well done to anyone that's been doing the GCSEs this time. I hope yesterday's exam went well. Okay, great. Right, perfect. Sound check is working, so that is all good. Okay, so I guess the best thing to do is actually to just get started with this past paper. So if you need a link to this past paper, I've put a link in the description. And other than that, I will continue to get going. Right, so here we go. Question 1 is, write 35% as a decimal. So if you want to go from fractions, if you want to go from percentages to decimals, what we do is we divide by 100. So we do 35 divide by 100. Remember, you've got your calculator for this here, so I'll bring my calculator out. Okay, so 35 divide by 100. And that equals 0.35. Next question. Here we go. We've got write 8,061 correct to the nearest 100. Okay, so we're looking at this number here. Well, the 8's not going to change, so I'll put that down there. So we're looking at 061. Is this closer? Well, the nearest 100, it's either going to go to being 000 for no hundreds at all, or it's going to go to 100. Well, 061 is like 61, and 61 is closer to 100, so this is going to become 8,100. Okay, great. Next one. Write down a number that is less than -5. So remember, with the number line and negative numbers, the number dictates how far away it is from 0, okay? So -1 is 1 space away from 0, -2 is 2 spaces, -3, -4, -5. So -6, so this is the funny thing, -6 is technically less than -5 because it's further away from 0, so it's still got further to go until we've got to 0. If you had -6 £, you'd have less money than if you had -5 £, okay? So we could have here -6. Right, let's look at this next one. Here is a grid of squares. What fraction of the grid is shaded? Okay, so here we go. We can see we've got 1, 2, 3, 4, 5, 6 shaded squares. And then we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Okay, so we've got 6 21s are shaded. It doesn't say to write this in its simplest form, so you could get away with 6/21. But if you wanted to write this in this simplest form, 6 and 21 are both divisible by 3, so we could call this 2/7. Now, because this is the calculator question, the paper, hopefully you'll have a fancy scientific calculator, which now means that you can eliminate the need for simplifying fractions. So you might have a button, I don't know if you can see it. There's a button here, and it's the fraction button. So if I press my fraction button and write 6 on the top, 6 on the top and 21 on the bottom, okay, I can see that's 2/7, okay. So there we go. So that is the other option there. But as again, it doesn't say simplified, so 6/21 should be fine. Right, let's have a go at this one here. Write down the value of 9 in the number 27,000. Sorry. Write down the value of 9 in the number 27.963. So this is your hundreds, tens, units thing. So place value goes hundreds, tens, units, and then you've got your decimals. And then we refer to these ones as 1/10 or tenths. The next ones here as 100ths. And these next ones as 1,000ths. So 27.963. So the 9 is in the tenths column. So the value of the 9 is 1/10. Is tenths. Let's call it like that. Tenth. I think get rid of the A actually, because that just sounds like it's 1. It's actually 9/10. So the value of the 9 is a tenth. Or maybe we could 0.9. It's a funny question. Let's move on. Okay, so here we go. In this question, we have got a pictogram. So the pictogram shows information about the number of chocolate cakes, vanilla cakes, and lemon cakes sold by Year 7 at a school fair. So here we go. We've got our key here, which shows us that the whole circle represents 12 cakes. So because there's 4 parts to the circle, I'm going to just quickly do 12 divided by 4. Okay, and then I'll do that on my calculator just because we have it. 12 divided by 4 equals 3. So that means that each part of this cake is worth 3. Okay. Right, so 24 cakes were sold by Year 7. Okay, fine. Use this information to complete the pictogram. 24 banana cakes were sold by Year 7. Use this information to complete the pictogram. So, if we know that each circle is worth 12, well, 12 add 12 makes 24. So we're going to need 2 circles here for the banana cakes. So that's 1 circle, 2 circles. So here we go. So that's 12, that's another 12. So that is now 24 cakes. At the fair, Year 8 sold a total of 150 cakes. Which year sold more cakes at the fair? Year 7 or Year 8? You must show how you got your answer. Okay, so let's look through this. We know that each whole cake is 12. So 12, 12, 12, 12, 12, 12, 12, 12, 12, 12, 12. Okay, we know each little bit of cake is a 3. Okay, so that's 3, that's 3, that's 3. Okay, so what I want to do is I want to do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I've got 11 lots of 12, so 11 times 12. Okay, I'll do that on the calculator. 11 times 12. And that equals 121. And then I'm going to do the 3 bits of 3. So 3 times 3 for the small bits of cake. So 3 times 3 equals 9. Okay, and now what we know, we've got 121 from the whole cakes. We've got 9 from the little bits of cake. So we've got 121, add 9. Okay, that equals 130. Okay, so Year 7 sold 130 cakes and Year 8 sold 150 cakes. Therefore, Year 8 sold more cakes. Okay, and the working out that we've done here shows that we know that what we're talking about. Okay, great. Let's have a look at question 7. Okay, so here it says here that Miklos is swimming lengths in a swimming pool. Each length of the pool is 25 metres. Miklos has swum 178 lengths. He wants to swim a total distance of 8,050 metres. Wow. Calculate how many more lengths Miklos needs to swim. Okay, so we need to know some things. We need to know how far has he swam already? Okay, and then we need to know how much further does he have to swim. Okay, or we could work out how many lengths. Okay, right, fine. So what we could do, well, yeah, let's work out how far Miklos has swam. Okay, so he has swam one length equals 25 meters, and he's swam 178 lengths. Okay, so that means I've swam 25 meters 178 times. Okay, so I'm going to times this by 178, and I'm timesing this by 178 as well. Okay, so let's do 25 times 178. Okay, so he swam 4,450 meters. Okay, so that's how far he swam. Now let's work out how far he's got left to swim. Okay, so we're going to have to do 8,050 take away 4,450. And again, this is the calculator paper, so let me just bring out the calculator again. So 8,050 take away 4,450. Okay, so that is 3,600. Right, so this is how many lengths he's got to swim. So we know now, so this time we know that one length equals the 25. Okay, we don't know how many lengths we're looking for, but we do know that they equal 3,600. So we need to know what we times 25 by to get to 3,600. So that's what we're looking for. 25 times something equals 3,600. So we can reverse that calculation and do 3,600 divided by 25. And let's see what that gets us. So here we go. 3,600 divided by 25 equals 144. Okay, so he's got 144 lengths left to go, because what we've done is we've times both sides of this by 144. Okie dokie, right, let's have a look at the next question. Okay, so here we go. We've got, I can't see what question this is now. Question 8. Here are a list of four terms of a sequence. Here are a list of 4 terms of a number sequence. So here we go. We've got 97, 91, 85, and 79. Explain how to work out the next term of the number sequence. Okay, so this number sequence will be increasing or decreasing by the same thing each time, presumably. So what we're going to do is we need to work out what have we taken away from 97 to get to 91. So we can work that out by doing 97 take away 91. Okay, so I'll do that here. 97 take away 91, and that equals 6. Okay, so this sequence is going down. Oh, is it? One second. Sorry. This sequence is going down in 6s. Okay, so here we go. We're going to have, so explain how to work out the next term. So we've taken away 6 here to get from there. Just check, 91 take away 6. Let's see. Does that work? 91 take away 6 gives us 85. Yep, so that's right. And let's just try the 85 take away 6. Take away 6. So that equals 7. Yep. So the definitely we can confirm that the rule for this sequence is that we're taking away 6. Take away 6. Right. Okay, here we go. We've got the next part of this question. Work out the difference between the 5th term and the 7th term of the sequence. Okay, right. So we need to continue the sequence on. So we know that the first term, I'll just write first, second, third, 4th, 5th, 6th, 7th. Okay, I'm just going to write these down. So these are the terms of the sequence. Our first term is 97, second term is 91, third term is 85, fourth term is 79. So I'm going to now just keep taking away 6 to continue on the sequence. So take away 6, 73, so the fifth term is 73. Take away 6 again. The sixth term is 67. Take away 6 again. Gives us 61. Okay, so now we've got our 7th term and our 5th term. When we see that phrase difference, that means we've got to take one thing away from the other. So when you're looking for the difference, you're looking for the gap between the two numbers. So we're going to do 73, take away 61, and that's going to give us the difference. 1 second. So here we go. 73, take away 61, and the difference will be 12. Okay, right. So the next point is explain why 52 is not in this number sequence. Well, in order to do that, let's just write down the next terms. So the 7th term, 8th, 9th, 10th. I think this will be fine to prove it. So if the 7th term was 61, the 8th term, let's bring out the old calculator again. The 8th term is going to be 61. Take away 6. So the 8th term will be 55. And the 9th term will be 49. So we have missed, here we go, we have missed 52. So 52 should have been between the 8th and the 9th term. Okay, so explain why 52 is not in the number sequence, because it lies between the 8th and 9th term. Okay. Right, there we go. Okay, hopefully that's okay. Let's have a look at the next question. Remember, if you want to pause these at all as well and have a go at them, that's fine as well, and then you can just kind of catch up otherwise. Otherwise, I'll just continue to keep going through. So here we go, question 9. And it says, Mandy buys a 12-kilogram bag of dog food. Mandy's dog has 3 meals a day. She gives her dog 105 grams of dog food for each of these meals. How many complete weeks will the bag of dog food last? You must show you're working. Okay, right, so things that we need to know. 1 kilogram is equal to 1,000 grams. Okay, that's the first key thing that we need to know here. And if you write that down, you probably actually get a mark for that. Mandy's dog has 3 meals a day, and she gives her dog 105 grams. So let's start playing around with that. So 1 meal equals 105 grams. 3 meals will be 3 lots of this. So 3 times 105. Okay. I know that a lot of these things with the calculator, you can do them in your head. But I'm just using the calculator each time just to encourage us to use it whilst we have it. It's not cheating to use the calculator. It is just a good thing to do. So we've got here 315 grams. Right, so we now know that 1 day takes 315 grams. Now what I want to do is, because the question is asking about complete weeks, I want to find out how many grams is a week. Okay, so I know that a week is 7 days. Okay, so I need to times this by 7, and so I'll need to times this by 7 as well. Okay, so if 1 day is 315 grams, 7 days is 315 times 7. Okay, here we go. So that's going to be 2,205 grams. Okay, so we now know what 1 week is. So 1 week equals 2,205 grams. So what we can now do is, I'm actually going to change this grams into kilograms, okay? So if I know here that 1 kg is 1,000 grams, well then, if I'm looking for 2,205 grams, what I've done is you can kind of see here, I'm going to just put the decimal place in. So 2.205 kg equals 2,000, so that's really bad, equals 2,205 grams. So let me just move this here. Oh, what's that? Let me move that up there. So here we go. So we know that 1 week equals 2.205 kg. So now what we can do is we can just count up in 2.205 kg until we get to 12 kg. So let's actually just bring my calculator on. So 1 week equals that. So let's do this. 2.205. So this is 1 week. So if I add another 2.205, that's 2 weeks. Okay, so I could write these down. I should do actually. So I'll write that down here. So 2 weeks equals 4.41. Add the 2.205 again. So 3 weeks is the 6.615. Let's go for 4 weeks. So plus the 2.205 again. So that equals 8.82. Ah, that's not 8.82. 5 weeks. So add another bag of another lot, 2.205. So that's 11.025. And then 6 weeks. Well, let's add it again, but I think we might go over 2.205. Yeah, so 6 weeks would be 13.23. Okay, so if I just move this again, so what we can see is 6 weeks is too much, 5 weeks is just under. So the question asks, how many complete weeks will the bag of dog food last? So the answer is going to be 5 weeks. Okay, so I can put that here. 5 weeks. Great. Okay, right. Question 10. So here is a polygon. The word polygon just means a shape with a number of sides. Okay, so write down the mathematical name for this shape. This shape has 1, 2, 3, 4, 5 sides. So it is a pentagon. Pentagon. Okay. In this bit, they're saying that it's a prism. So a prism is a 3D shape which has the same shape all the way through. So that's what this now is. So each edge of the prism has a length of 7.5 centimeters. Okay, so that they're referring to these bits. Okay. Oh no, each edge. So every single edge of this prism has a length of 7.5 centimeters. Okay, so every single one. So 7.5 here, 7.5 there, 7.5 there, 7.5 there, 7.5 there. And then we've got the 3 ones that go back. Ah, that wasn't a back one, that was a... let me get rid of that. So we've got all of... there's going to be 5 lines here that go back. Okay. And then there's going to be 5 lines here as well at the back. So 5 lines there. Okay, so we've got a lot of 7.5s there actually. We've got 5 lots of 7.5 at the front. We've got 5 lots of 7.5 in the middle. And we've got 5 lots of 7.5 at the back again. So, yeah, so we've got 7.5, 5 times, 3 times. Okay, so let's work that out. So 5 times 7.5, I'll get the calculator out. 5 times 7.5 is 37.5. Okay, so we're going to have 37.5 centimeters for all the edges on the front, 37.5 centimeters for all the edges in the middle, and 37.5 centimeters for all the edges on the back. So let's add these all together and see what we get. So 37.5, add 37.5, add 37.5. And here we go, that's 112.5. Okay, let's move on. Here we go. Whew. Okay, so here we go. Oh, let me move my calculator. We've got here a chess match lasted 3¼ hours. The match finished at 14:10, which is 10 past 2. What time did the match start? So we've given here 3¼ hours. What is quarter of an hour? We all know, we should know this. If someone says, I'll meet you at 11:45, or 12:15, or I'm going to be quarter of an hour, what we're talking about, quarter of an hour, is 15 minutes. Okay? So what we've got here is a chess match lasted 3 hours and 15 minutes. Okay? The match finished at 2:10. At what time did it start? Okay, so we're going to have to go backwards here. So let's think about this first. I'll start down here. Okay, let's go back 3 hours first. So 1 hour would be 13:10. 2 hours would be 12:10. 3 hours would be 11:10. Okay, so 3 hours here. So this is 3 hours ago. So we're at 11:10. Now we've got to go 15 minutes ago. So, well, 10 minutes ago will take us till 11. Will take us to 11. And then we've got to go 5 minutes back from that. So 5 minutes back from 11 will take us, well, we'll go down to 10, and that'll be 55. Okay? So the match would have started at 10:55. Right, let's have a look at question 13. Okay, so 13a says, simplify 8h cubed plus 14h cubed minus 2h cubed. Okay, so they are all the same sort of thing. They're all h cubes, so we can forget about that. We don't have to worry about this bit too much. We've just got to sort out the numbers, okay? So, and we've got our calculator, so let me bring my calculator onto the screen. Okay, so we have got 8h cubed plus 14h cubed, and then minus 2h cubed. So if the symbols are the same, we can just do what we want with the numbers. Okay, so that equals 20. So that's going to be 20h cubed. Oh, 20h cubed. Right, part B. Simplify 9y plus 12y divided by 3. Okay, so again, we can just, they're both y's, so we can just add those together to start off with. So 9 add 12, again, I'm just being lazy because I've got my calculator. 9 add 12 equals 21. So here we've got 21y divided by 3. Now remember, this is like we've got 21 y's, okay? So dividing them by 3 is like putting the 21 y's into 3 groups, okay? So we'd put a y here, 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 a y here. So basically what we can see what we're doing is we're actually, although we're doing 21y divided by 3, it's actually just the same as 21 divided by 3 with a y there. So I'm actually just going to do 21 divided by 3. Okay, and 21 divided by 3 is 7. So 21y divided by 3 will equal 7y, because if we divided all those y's into all those groups, we'd have 7y in each group. Okay, right, question 14. Write the following numbers in size order and start with the smallest. Okay, so I'm going to get out my calculator again for this. Let me scroll that up so that I can fit everything on the screen. Okay, so I am just going to turn all of these into percentages, I think. So remember, to convert a fraction into a percentage, we do top divided by bottom to turn it into a decimal, and then we times it by 100. Okay, so 7 over 12, it will be 7 divided by 12, and that equals that. And then if we turn it into a percentage, we get 58.3%. 56, to go from a decimal to a percentage, we just times by 100. So 0.56 times 100 equals 56%. 57% is obviously 57%. Let's do 6 over 11. So 6 divided by 11 equals this. Then times that by 100 to turn it into a percentage. So here we go. We've got 54.5%. And then 0.558. 0.558. If I times that by 100, this will equal 55.8%. Okay, so now we can put these in size order. Now we're looking for the smallest first, so the smallest one is this 54%, so I've got to write down the 6 over 11. The next one is the 55%, so I've got to write down the 0.558. After that, what we've got is we have got the 56%. So I've got to write 0.56. Then we've got the 57%, so which I can actually write as 57%. And then lastly, our largest one is this 58.3%. So I'm going to write that as 7 over 12. Right, I'll be back in 1 second. Have a think about that. I'll see you soon. Okay, sorry about that. Okay, right, so let's have a look at the next question. So here we go, we've got question 15, and this says a travel agent sold 100 holidays in April. Each of these holidays was in the UK or was abroad. 64 of the holidays were sold to families. The rest of the holidays were sold to couples. 11 of the 18 holidays were sold to couples. Use this information to complete the frequency tree. Okay, so, right, 64 of the holidays were sold to families. Okay, so if 64 has gone there, then in this bit, I've got to put the number that adds to 64 to get to 100. So remember, if 64 adds something equals 100, then 100 take away the 64 will equal that something. So I've got to do here 100 take away the 64. So 100 take away the 64, and that will be 36. So here we go. So we've got 36 couples. Right. Next bit. Okay. So the next bit that we've got here is we've got 11 of the holidays abroad were sold to couples. Okay, so 11 holidays abroad were sold to couples. So we're in the couples section here, so 36. So 11 holidays abroad were sold to couples. There was 18 holidays. Right, so basically the 11 holidays plus the rest of the holidays equals 18, if that makes sense. So we've got 11 to couples, and then the rest were to families, and that makes 18. So I'm going to do 18 take away 7. No, I'm just thinking of the answer. 18 take away 11, which will equal 7. Okay, so here we go. We know that 7 of the holidays, the remaining 7 holidays abroad, went to families. So here we go. So a 7 goes here. So now what we've got to do is we've just got to fill in these blanks. So if we've got 64 families, 7 of them went abroad, then the rest of them went to the UK. So let me put this here. So we're just going to do 64 take away those 7. Okay, that's going to equal 57 here. And for this bit at the bottom, we're going to do if 36 of the couples went abroad, if there was 36 couples, 11 of them went abroad, so we'll do 36 take away 11, and that means that the remaining 25 stayed in the UK. Right, there we go. So here we go. One of the holidays sold to a family is chosen at random. Okay, so we're only looking at the family holidays. Okay, let's be very clear at that. One of the holidays sold to a family is chosen at random. Okay, find the probability that the holiday was not abroad. Okay, so, well, if we're looking only at these 64 holidays, that's our base. How many of them were not abroad? Well, it was 57 out of 64. Okay, it does not say about simplifying your fraction, but again, if you've got a fancy calculator, you can type 57 out of 64 into your calculator, and that will simplify if it can. Let me find out if it does. 57 out of 64. And it doesn't. So there we go. We've got our answer, 57 out of 64. Okay, great. Right. Let's solve this question. So this question here says, something divided by 7, add 9 equals 4. Okay, right. So first of all, let's just think about this. What add 9 equals 4? Okay, something add 9 equals 4. Well, in order to do that, remember, if we've got a question like this, if two things add to make another number, then we just have to do that number take away the other one to get the remainder. So we'll do the 4 take away 9. I'm going to do that on my calculator. 4 take away 9 equals minus 5. Okay, so minus 5 add 9 equals 4. Okay, so let's double check that as well. Does minus 5 add 9 equal 4? Yes, it does. Okay, right. So we've done the first bit. So we now know that this bit here must be equal to minus 5. So we know that x over 7 equals minus 5. Now, something divided by 7 equals minus 5. So remember, if something divided by something equals something else, then this bit here, x, it must equal this minus 5 times the 7, okay? You might have seen the formula things that you do in science. So we've got here the x at the top, we put the 7 there, and we've got the minus 5. So let's check this out. Minus 5 times 7, let's see what it gives us. So 5, make it negative, times 7 equals minus 35. So x equals minus 35. And we can double check this. So let's have a look. So minus 35 divided by 7 equals minus 5 plus 9 equals 4. So that is correct. Okay, great. Ooh, we've got a bit of a long one here. Right, let's have a look at question 17 and see what's going on with Blake. So Blake works Blake works 32 hours a week in the UK. She is paid £473.28 per week. Blake applies for a job in Australia. The rate of pay is 26.4 Australian dollars per hour. £1 is equal to 1.796 Australian dollars. Blake thinks the rate of pay in Australia is greater than the rate of pay in the UK. Is Blake correct? Okay, so we need to work out how much Blake earns per hour in the UK. So we know that in 32 hours, she is paid £473.28. Okay, so we want to go down to 1 hour. Okay, so remember, rates of pay are directly proportional. So anything you do to one side, you can do to the other. So if I'm going to divide this by 32, I also divide this by 32. Okay, and then we're going to get the hourly rate. So let me bring out the calculator and do, where can I put it? Yeah, it's quite big. I'll put it here for the time being. Yeah, I can see those numbers. Okay, so we have got 473.28 divided by 32. Okay, so this is 14.79. Okay, so Blake earns £14.79 per hour in pounds. So if we know that £1 equals 1.796 Australian dollars, well, we need to get 14.79 pounds. Okay, so in theory, we're doing 14.79 lots of this. So we need 14.79 lots of this. Okay, so let's do that. Well, we've already got the 14.79 there, so let's just times this by the 1.796. Okay, here we go. And so that is 26.56 Australian dollars. Okay, so actually, what does that mean then? Is she going to get paid better in Australia? No, she's not. It sounds like so much more money, 26.4 Australian dollars per hour. But actually, she's getting paid more when she earns £14.79. Okay, so is Blake correct? You must show how you got your answer. No. Yeah. We've shown it here in our working out. We don't have to write anything else there. No, she is not correct. Okay. Right. Question 18. Oh, we've got a shape. Here is a shape made of a triangle, from a rectangle and a triangle. The shape has exactly one line of symmetry. Okay, which means it's an isosceles triangle. The area of the rectangle is 3.5 times the area of the triangle. The width of the rectangle is W. Work out the value of W. Right, okay, so it sounds to me like the first thing that we want to do is find out the area of the triangle and then times it by 3.5 so that we have the area of the rectangle. And then once we've got the area of the rectangle, we can worry about finding W. So, if this line here is 3.8 and it's symmetrical, this is going to be 3.8 as well, which means that this distance here is going to be 14 centimetres, take away this 3.8 and take away that 3.8. So I need to work out 14, take away 3.8, take away 3.8. Okay, so let's get the calculator out. So here we go, 14 minus 3.8 minus 3.8. So here we go, that length there is 6.4 centimetres. So now what we need to do is work out the area of this triangle. So the area of a triangle, area triangle is equal to half base times height. Okay, so let's work that out here. So we know that we know that a half is a half. I'm going to write it as 0.5 times 6.4 for the base times 6 for the height. Okay, so that's all we need to do for that. So I'm going to just do that on the calculator. So we've got 0, oh no, sorry about that. We've got 0.5 times 6.4 times 6. So that area of that is 19.2 centimeters squared. Remember, we measure shapes in squares. Right, next we need to know the area of the rectangle. Now here we go, we said it's 3.5 times the area of the triangle. So we're going to have to do this 19.2. So that means we're going to have to do 19.2 times 3.5. Okay, so 19.2 times 3.5 equals 67.2. And that will be centimetres squared as well. Okay, 67.2 cm squared. Right, now what we've got is we need to work out W. So the area of a rectangle equals length times width. So in other words, our area is equal to 67.2 times W. Okay, so if we know that two things... no, it's not. Our area is equal to length times width. Let's do that again. So the area equals length times width. Let's replace what we can. Okay, so the area is 67.2. The length is 14. And the width is W. Okay, so what we've got to do here is we've got 67.2 times 14 times W. And so I need to rearrange this in order to find out what W is. So if two things multiply together to give a third thing, which is the product, then the product divided by one of the other two things gives us the other thing. So we're going to do 67.2 divided by 14, and that will equal W. Okay, and then we can test it back later. So let's do 67.2 divided by 14, and that equals 4.8 centimetres. Okay, and let's just check. 4.8 times 14, does it give the right area? And it does. Excellent. So there we go. That's perfect. Right, okay. Let's move on to the next one. Ooh, we've got a picture. The front elevation of a cuboid is shown on the centimetre grid below. Okay, so the front elevation means when you're looking at something directly on, and it's like the 2D shape that's at the front of something. So if you had no depth of perception, no perception of depth, that's what we'd be getting. So let's have a look here. What else does the question say? The volume of the cuboid is here we go. The volume of the cuboid is 224 centimetres cubed. On the grid, draw the plan of the cuboid. So the plan is the view from above. So this is the view from the front. So we've got the length here, which is 1, 2, 3, 4, 5, 6, 7, 8. So this is 8 centimetres. And we've got the height, okay, which is 1, 2, 3, 4. The volume of a cuboid is equal to length times width times height. So we know that it's going to be 8 times 4 times the third dimension. Okay, I've said that that's the height, so let's call it the width maybe. So here we go. So 8 times 4 times W is going to equal the volume of the cuboid. The volume of the cuboid is 224. So let's work out what we know here. So we can do 8 times 4. 8 times 4 is 32, I believe. 8 times 4. There we go. 8 times 4 is 32. Let's just move that over there. So we know that 224 equals 8 times equals 8 times W, which means that W will equal 224 divided by 8. So let's work that out. 224 divided by 8. Ooh. No, sorry, I meant to write 32. Sorry about that. I was thinking, you know what? I looked at that answer and I was like, there's no way that I can draw a 28 centimetre line on that piece of paper. So I must have gone wrong. So that should be 32. So what we're looking for is we're looking for 224 divided by 32. So 224 divided by 32. So that's 7. So the third dimension of the cuboid is 7. So what we've got to do is if we kind of picture our cuboid like, okay, we just need to think about what's going on. Okay, I'll move that there. So this is our cuboid here. We've got this 4x7, this 4x8 thing even. And then what's happening is it's going back 7 centimetres, okay? So we've got 8 here, we've got 4 here, and this dimension is 7. So all of these lines here are the 7. All of these lines here are the 8. And all of these lines here are the 4. And there'd be a little sneaky 4 there as well. So what we need to do is we need to work out the dimensions from the plan view. So the plan view is the top of the shape, okay? So the plan view is actually this rectangle here, okay? So this rectangle, this is 8 and this is 7. So the plan view of this cuboid is an 8x7 rectangle. So let me just move this now. And then let's draw that 8x7. Oh, it didn't work. There we go. Move that over there. So our plan view is the 8x7 rectangle. So we've got here 1, 2, 3, 4, 5, 6, 7. Is that 7? 1, 2, 3, 4, 5, 6, 7. Yep. And then 8 this way. Here we go. Obviously use a ruler. Okay. But this is the plan view because the plan view is the view from above. Okay, great. Let's continue on. Right, question 20A. Write 468,000 in standard form. So this is, standard form is when it's something point something times 10 to the power of something. Okay, so it's always, so you're always going to have a decimal place in there. So basically, you only want one number in front of your decimal place. So this is going to be 4.68. Okay, and then we're going to times it by 10. And then you count the numbers after the first digit. So 1, 2, 3, 4, 5. So 4.68 times 10 to the power of 5. And then obviously you can always check that on your calculator if you go into scientific mode. Scientific. Here we go. So let's see if I've got that right. 4.68 times 10 to the power, is this going to work? 5? Yay! Okay, great. So there we go. And let's see. And then that has, it's got 4, 6, 8 and 3 zeros. Yes, this is the same number as that, so I know that that has gone correct. Okay. So always remember to check your answers where you can. Let's go back to basic calculator. I'll move to the side. Oh no. Something's gone wrong. What's gone wrong? No, nothing. It seems to be working. Okay, fine. Right, so let's do that here and move that over to the side. Right, so next bit we have got part B. Write 5.037 times 10 to the minus 4 as an ordinary number. Okay, unfortunately, your calculator won't work to help you out with this one because if a number on your calculator is a number that would normally be written in standard form, it will actually give it to you very unhelpfully in standard form. Okay, so let's have a go with this one. So, but if you see minus 4 here, what that means is there's going to be 4 zeros in front of your number. Okay, 0, 0, 0, 0, 5, 0, 3, 7. But you must put a decimal point after the first 0. Okay, so there we go. So we've got 0.0005037. Okay, so next one. Here is a biased spinner. The biased means that it favours one number over the others. The table shows the probability that when the spinner is spun, it will land on A and B, on C and on D. Luca will spin the spinner 200 times, work out an estimate for the number of the times it will land on spinner A. Okay, so you can actually think about decimal probabilities like in a similar way we do with percentage multipliers. So in order to answer this question, all we simply do is do the probability multiplied by the number of times we're going to spin it. Because this is like 0.4, it's like saying 40% of the time. So we just do 0.4 times 200, and that'll equal 80. Okay, right, there we go, perfect. Answer done. Estimate the mean. Okay, so Sager works at a weather station. The table gives the information about the temperature, T degrees, at midday for each of 50 cities in the UK on Tuesday. Okay, right, calculate an estimate for the mean. The reason why it's an estimate for the mean, it's just because we don't know the exact values, so we have to make an estimate of what we think the values are. So in this first one, they are all between 10 and 15. Okay, so in order to get my estimate for those, I'm just going to do 10, add 15, and then divide that by 2. So 12.5. These are also known as your midpoints, okay? And we just get them by doing the first number, add the second number, and dividing it by 2. So the next one, we've got 15, add 20, divide by 2, 17.5. Then we've got 20, add 25, divided by 2. Oh, what happened there? Oh no, I didn't divide it by 2. 45 divided by 2. 22.5. Next one. 27.5. And then okay. Now what we do is we now need to think about our more classic mean strategy. So the means, when we work out the mean, we're kind of adding everything together and dividing it by the number of things. So here we've got 2 people that we've estimated had the temperature of 12.5 degrees. So we need to do 2 times 12.5. Okay. Here we've got 8 occurrences of 17.5 degrees. So we need to do 8 times 17.5. Here we've got 13 occurrences of 22.5 degrees. Here we've got 21 occurrences of 27.5 degrees. And here we've got 6 occurrences of 32.5 degrees. So let's calculate all of these and add them together. So here we go, we've got 2 times 12.5. So that's 25. We've got 8 times 17.5. That's 140. We've got 13 times 22.5, which is 292.5. And then we've got 21 times 27.5. That's 577.5. And then we've got 6 times 32.5. And so that equals 195. Okay, so this here is, if we add up all of these, this is all of the temperatures of all of the cities added together. So remember, your mean is equal to the total total things added together by the number of things. Okay, so in order to finish this question, sorry, that handwriting was appalling. In order to finish this question, what I've got to do is I've just got to add up all of these numbers for the top, and we know that there's 50 cities, so we're going to have to do all of these numbers added together, divided by the number of cities. So we'll have to do 25, add 140, add 292.5, add 577.5, add 195. There we go. 1230. And then if we do that divided by 50, that's 24.6 degrees C. And that is our estimate of the mean. And that actually makes a lot of sense because that is roughly in the middle of all of these values. So your mean should make sense once you've calculated it. Okay, right. Sager says the median temperature is 22.5 degrees because 22.5 is the middle number in the middle group. Is Sager correct? 22.5 is the middle number in the middle group. It sounds like she's wrong. 22 point... Yes, she's very much wrong. The median is the middle value when you've put all of them in order. But that's not the case with here. So, no. Median is the middle when all data points are put in order. She has just gone for the median of the table. Okay, right. Let's have a look at this next question here. So, question 23, it says, Jenna is asked to show the inequality -3 is less than x is less than or equal to 4 on the number line. Here's her answer. Write down 2 mistakes. So first of all, if you see this symbol here with the equal, then you need to colour it in. So she should have coloured in the circle above the 4. Okay, the second thing is, it's actually greater than -3. So this circle here should have actually gone down to here. Because all of these values, like -2.5, -2.6, they would be included within that inequality. Okay, so the lower circle should have been above 3, -3. Okay, work out the greatest integer that satisfies the inequality 5y minus 7 is less than 16. So integer means whole number. Okay, so let's take a look here. So we've got here 5y take away 7 equals 16. So let's think about this. Well, what take away 7 equals 16? Okay, so we can add those together. So if we add, we get 23 take away 7 equals 16. Okay, so therefore 5y must be less than 23. Okay, so if 5y take away 7 is less than 16, 5y has to be less than 23. Okay, because any number larger than 23 take away 7 is more than 16. For example, if you tried 24 take away 7, that would equal 17, which is not less than 16. Okay, so let's have a look now. We've got 5y has to be less than 23. Okay, what we can do here is if we divide both sides by 5, in a very similar way to our direct proportion, we'll find out what y has to be less than for this to work. So we've divided that by 5, so let's divide this by 5. So I'm going to do that on my calculator. So 23 divided by 5 equals 4.6. Here we go, 4.6. So y has to be less than 4.6. So work out the greatest integer that this could be. So the greatest integer would be 4. Because if y has to be less than 4.6, it can't be 5. And the first whole number less than 4.6 is 4. Okay, right, question 24. Ali buys packs of balloons and boxes of pencils. There are 30 pencils in each box. There are 30 balloons in each box, sorry, and there are 24 pencils in each box. Ali buys exactly the same number of balloons and pencils. Work out how many boxes of balloons and pencils she has to buy. Okay, so basically we're looking for the lowest common multiple of these two things. So we're looking, imagine if you counted up in balloons. So if you had 30, 60, 90, 120, 150, 180, okay, 210. These are the number of balloons you're going to have if you're buying balloons in bags of 30. If we're buying pencils in boxes of 24, we're going to have 24, 48, 48 add 24, which will be 62, 52, 72, 96, 120. Ah, here we go. We've got there. So the number of boxes they need this many and this many. So if they want the same amount, it's got to be 120 balloons and 120 pencils. And 120 balloons is 1, 2, 3, 4 packs of balloons. And 124 pencils is 1, 2, 3, 4, 5 boxes of pencils. Oh, there's another question down here. A company orders a large number of plates from a factory. It would take... this question. This is a funny question. Question 25. Right. A company orders a large number of plates from a factory. It would take 30 hours to make all the plates using 4 machines. Okay. How many machines would it need to make all the plates in 6 hours? Okay, so what we need to do is we need to work out how long or how many hours it takes one machine to make these plates. Okay, so if 4 machines take 30 hours, then 2 machines would take twice as long, would take 60 hours. 60 hours. Okay. And 1 machine would take 120 hours. Okay. So, So here we go. We've got 1 machine would take 120 hours to do it. So we need to get 6 machines. But, we need to do it in 6 hours. So it would take 30 hours to make all the plates using 4 machines. Okay, right. So where are we going to go from here? Right. So we know that 1 machine takes 120 hours. We know 4 machines take 30 hours. We need to get down to 6. Maybe we should have gone the other way round. So if 4 machines take 30 hours, 8 machines would take 15 hours. That's not going to help us. I know what we need to do. Right, we need to get this to be a 6, okay? So, do you notice what's happening here? If we divide this by 2, we times this by 2. So this is called inverse proportion. So what we're doing to the one side is the opposite of the other. So we need to get to 6 hours doing this. So actually what I'm going to do is let me move this down to here and down to here. So I actually know that I want this to be 6 hours, okay? So what do I need to times 6 hours by to get to 30? Well, I need to times 6 hours by 5. Okay, so that means this side would have had to be divided by 5. So it would be 20 machines. Okay, so 20 machines in order to do 6 hours work. So there we go. So 20 machines. That was confusing. Okay, right. Question 26. Riley travelled by car and aeroplane. He travelled 143 miles by car at an average speed of 55 miles per hour. Riley then travelled for 5 hours at 20 minutes. For 5 hours and 20 minutes by aeroplane. Work out in hours and minutes Riley's total travelling time. Okay, so right. So he did 143 miles at an average speed of 55 miles per hour. So in 1 hour, he does 55 miles. That's what that means. So we want to get to 143 miles. Okay. So what times 55 gives us 143? That's what we're looking for. What times 55 equals 143? So I need to do 143 divided by 55. Okay. So let's get the calculator out for that. So 143 divided by 55. 2.6, okay? So 2.6 hours. So this is decimal time at the moment, so don't confuse this with minutes. So 2.6 hours is how long he spent travelling by car. Then he travelled for 5 hours and 20 minutes by aeroplane. So we know that he's travelled 7 hours and 20 minutes plus 0.6 of an hour. Okay, right, so 0.6 of an hour is 0.6 of 60 minutes. So we'd do 0.6 times 60, and that will tell us how many minutes that was. Okay, so here we go. 0.6 times 60 equals 36. Okay, and now we know that that bit was 36 mins. We can add that onto the 20 mins. And so that's 56. Okay, so there we go. It's going to be 7 hours and 56 minutes. Right, let's continue going on. Question 27. The diagram shows a solid cube placed on a horizontal table. The pressure on the table due to the cube is 3.5 newtons per centimetre squared. The force exerted by the cube on the on the table is 504 newtons. Show that the total surface area of the cube is less than 900 centimetres squared. Okay, fine. Right, so let's just fill in what we can. So we know that the pressure is 3.5. We know that the force is 504. And then we know that this is the area. Oh, okay, this will be okay. So we've got two things and we can work out the third. So you might have done these in science again with your triangle. So if I've got the 504 here, I can do the 3.5 and then the area here. So the area will equal 504 divided by 3.5. Okay, I'm going to do that with my calculator. 504 divided by 3.5 equals 144. So that means that this is the area of each face of this square. Okay, so this one is 144, this one is 144, this one's 144, this one's 144, this one's 144. I've missed one because it's confusing because this the front one's 144. Anyway, there's 6 faces of the cube and all of them are 144. So what we can do is we can do 6 times the 144 equals, let's find out, 6 times 144, 864. There we go. So we've shown here that the total surface area is less than 900 centimetres squared because we've shown that it's 864. Okay, right. Question 28. The line on the grid The line L is shown on the grid. Find the equation of line L. So this is a straight line graph, so it will be of the form y equals mx plus c. Okay, m is the gradient, and that tells you how many squares in the y it's going up or down for every one square across. So this graph is going downwards, okay, and I can see that for one square across it's going down 2. So if it's going down 2 squares for every one square across, that means that this is of the form y equals negative 2x, because it's going down, okay. And then c, this one here, c is where it crosses the y-axis. So this is crossing the y-axis at this 3, so this will be y equals minus 2x plus 3. So that's where that information has come for this line. So y equals minus 2x plus 3. Okay, right. Question 29. A, B, C, D are the points on a circle such that A, B, C, D is a square. The square has side lengths of 3.5. Calculate the circumference of the circle. Give your answer to 1 decimal place. Okay, this is a square, so all sides are 3.5. Now, to find the circumference, we do pi times diameter. We don't have the diameter. The diameter is the distance from corner to corner of this square. Oh, that didn't help. This is the diameter here. But we can work this out because this is a square. And if we cut this square in half, what we get is we get a nice right-angled triangle like this, with 3.5 here, 3.5 here. And so we can use Pythagoras' theorem, which is a squared plus b squared equals c squared, which means that this length is equal to this squared plus this squared. So let's do 3.5 squared plus 3.5 squared equals c squared. Okay, so let's do this. We've got 3.5 times 3.5 equals 12.25. So if we do 12.25 plus 12.25, that equals 24.5. So if that means that this length squared equals 24.5. So in order to find out what that length actually is, we need to square root it. Okay, so I'm not going to do anything with that yet though, because we haven't finished. I am just going to leave this length here as the square root of 24.5. So I'll just make a note here, root 24.5. Okay, so the diameter equals root 24.5. Okay, oh, now we can simply just complete the question by doing pi times that and then rounding it. So pi times the square root of 24.5. Let's do that on the calculator to find out what that equals. Okay, I'm going to have to go scientific for this. Scientific. Okay, so here we go. We've got pi times the square root of 24.5. Close that bracket. Here we go. 15.5500. They only want it to 1 decimal place, I believe. Let's go. Here we go. Give your answer correct to 1 decimal place. Show all you're working out. So to 1 decimal place, that's looking at here. So 15.5 will become 15.6 because this number is large enough that we decide that this section needs to be represented in the 1 decimal place. So we round that up. Okay, and there we go. 15.6. Excellent, and that's the end. Okay, well done if you got to this stage. There's actually quite a few of you watching. I mean, well, a few for me anyway. So thank you very much for watching, and I hope this was useful, and I hope your exams have been going well, and good luck, and see you soon. Okay, or not, hopefully. Right, bye.